Hello, and today I am going to show you how various transformations can be applied to basic functions. The function we are working with today is the absolute value function. We will be graphing y equals -3 to, open bracket, x plus 2, close bracket, plus 5. I will start off by graphing the basic function. The points that I will use throughout this video will be -2, -1, 0, 1, and 2. The points for our first graph are -2, 2, -1, 1, 0, 0, 1, 1, 2, and 2. The first transformation our graph experiences is a vertical stretch by a factor of 3. This is a stretch because the factor 3 is greater than 1. We are multiplying all of our points by 3, making our new coordinates. -2 becomes 6, -1 becomes 3, 0 is still 0, 1 becomes 3, and 2 becomes 6. Our next transformation is a horizontal stretch. Now at first it would appear that we have no horizontal stretch or compression, but we must remember that you can always factor. In this case, we can factor out a 2, so the graph experiences a horizontal stretch by a factor of 2. The new y points are multiplied by 2. -2 becomes 12, -1 becomes 6, 0 is still 0, 1 becomes 6, and 2 becomes 12. The next transformation is the reflection. Now, since the negative sign is placed in front of our first value, the reflection is over the x-axis. This will turn our positive y values into negative values. -2 becomes -12, -1 is -6, 0 is still 0, 1 is -6, and 2 is -12. Next, our graph experiences a horizontal shift to the left by 2 units. Though our function said by 4 units, we must always factor where we can, as with the horizontal stretch. We are shifting to the left by 2 units and not 4. Our new points are -2 is 0, -1 is -6, 0 is -12, 1 is -18, and 2 is -24. Finally, the graph has a vertical shift up by 5 units. We are adding 5 to our previous y coordinates. -2 becomes 5, -1 is -1, 0 becomes -7, 1 is -13, and 2 is -19. It is easy to mirror points on this graph as it functions similar to a linear function in that the points are symmetrical.